Today we are going to be looking at a developmental network between genes using Disney's Hercules as an example. We will use the characters Zeus, Phil, Hercules, Meg, and Hades. The Zeus gene product stimulates the transcription of Phil. It is an activator. In the movie, it is Zeus's lightning that strikes Phil, proving that Hercules is Zeus's son and that Phil should help Hercules, which leads to our next point. The Phil gene product stimulates transcription of Hercules, so it is also an activator. Phil's character helps Hercules get in shape and learn to fight evil so that young Herc can prove himself a hero and rejoin his father in Mount Olympus. In the movie, Hercules is introduced to a young woman named Meg, who has sold her soul to Hades in exchange for the freedom of a former lover, who then left Meg. So, the Hades gene product represses the Meg gene, and as long as Hades is there, the Meg gene cannot be transcribed. That is where Hercules comes in. Hercules loves Meg, and as the fates predicted, if Hercules fights, Hades will fail. So, when the Hercules gene product is present, Hades is inhibited, and the Meg gene is free to be transcribed. Let's map this out using arrows and T-arrows. Arrows will represent activators, the promotion of the gene to the right of the arrow, and T-arrows will represent repressors, the inhibition of the gene to the right of the T-arrow. So we have Zeus, arrow, Phil, arrow, Hercules, T-arrow, Hades, T-arrow, Meg. Zeus promotes Phil, who promotes Hercules, who blocks Hades, who is repressing Meg. Now, what if there was a mutation in one of the genes above? Let's look at a few examples. Let's say the Hades gene is mutant, so Hades is removed from the system. If this is the case, then Hades will not be repressing the Meg gene, and Meg will be free to be transcribed. Now, what if the Hercules gene is mutant, so Herc is removed from the system? If this is the case, then the transcription of Hades will not be inhibited, and Meg will remain in servitude to him. Now, what if two genes are mutant? Let's say Zeus is mutant and Phil is mutant. Neither Zeus nor Phil are present, so Hercules will not be transcribed, and if Hercules is not transcribed, as we saw before, Meg will remain repressed by Hades. For our last example, let's say the Hercules gene and the Hades gene are both mutant, so neither Hercules nor Hades are present in the system. Well, Hercules' absence is less significant now that Hades is also absent, because in that case, Meg goes free because Hades is not there to hold her captive. I hope you enjoyed learning about developmental networks with the use of Disney's Hercules. See you next week!